let me catch you up on what I've been working on since I last streamed. So, there's something called the 3 cell well patterns, pattern recognition. Okay, so you have these sets of patterns that apply to a grid 3-celled Y. And these are all the combinations of shapes that you can make using the 7 Tetris pieces with the following stipulations. There's no eyepiece, and um, a piece is only used up to 2 times. So pretty realistic. You're very likely not going to be in a situation where you're placing 3 pieces of the same type in a row. So no LLLs, no OOOs, and so on. The only time that situation would arise is if you have, say it's 3 Ls, an L piece in hold, an L piece at the end of a bag, and an L piece at the start of your next bag. Those would be the only times you would have 3 pieces in a row in Tetris Guideline, which uses the 7-bag random generator. So I noticed when I went to study these, this list is not complete. So if you take a look at something like, I'm sure we can come up with something. Let's take a look at, I don't know, how about this one, 001. Oh, by the way, this naming, this nomenclature 001 is describing the terrain. So you have no gray, and then 1 gray. So that's the 001, and this is just the reverse. Now, I'm sure if we looked at this long enough, we could find a missing combination, but I know there's definitely missing combinations. That's what prompted me to generate these myself in the first place. So here are all the combinations, okay? Let's say, actually, let's take a look at the one that had only one example, 010. What did my algorithm come up with? 010. Let's try this. Okay, 2 solutions. So actually, that one is complete. Let's take a look at something else. How about 023? My 023 is a little larger in size, so I think it's, oh, yeah, so we've only got that. Okay. Anyways, there's definitely missing ones, especially when you count eyepieces. So in this set of solutions, I generated all patterns for each of the terrains that don't have an eye. So here's patterns no eye. If we go up a directory, I also generated patterns. So if you look at this set, these solutions have eyes in them, and there's quite a difference in the cardinality of the results when you include the eye or not include the eye. Okay, so you can see here, you've got eyes in your solution, which means you can place your pieces in such a way that you have an eye dependency, which is a lot of ways, and it's also not optimal. So it's useful to train both for eye dependencies and without eye dependencies. So usually you would never place a J and a T like this, because you know the only piece you can place here is an I. So um, it'd be useful not to have to train for it at first, at least. Um, that training will come later. It's going to come eventually because eyepieces are in the game, and you do have to uh, pattern recognize for eyes. But as you can see here, for the 000 set, as you can see, these are all, there's no gray pieces on the bottom, so this is a flat terrain. Um, so for all combinations of the rule, no more than two pieces per solution. Then you have 76 distinct solutions. Okay. Now for the no eye solution set, as you can see here, there's no eyes. There's only 50. So that's like a 50% difference in the number of patterns you'd have to remember. Well, not remember. The point of this is not to memorize. The point is to the point is not to memorize. It's to familiarize and recognize on the fly. So let's say you had. So what's the point of this? Let's say you had an OJJ coming up in your queue, and then you notice that you have a flat terrain. Oh, so I can probably, I can play something like this, OJJ. And you can do that without thinking if you've seen these patterns enough. Okay, so that's where this will come in. The difficulty comes in just how many patterns there are in total. So as you can see here, you've got all these different combinations. And not all of them are going to have a lot of solutions. For example, the 010 without I. Okay, this one is the eyes. Let's see. I think this one has only one solution. 020. Or maybe no solutions. Yeah, this one has no solutions because if you have a 020, then you can't place anything without an I. Right? If you have a J, then immediately you have a I dependency here. So there's no solutions for this. See, this one is moderately sized. It's only 17 for 101, as opposed to the 50 for 000. And again, this is where pattern recognition would come in handy. Like, let's say you've got TJL coming up in your queue, and you have this pattern. You know you can place it, and then you know the resulting piece will be 011. And of course, this logic sort of stacks. So if you don't necessarily want to place the T, J, and L like this, you know that at least you can place the T and the L, and you'll have a 220 resulting, and then you can play with whatever 220 pieces that will fit this pattern. So for instance, I'm a little familiar with this, so you can place an I piece here, you can place an O here, you can place an L here, and then that becomes a 011. Then you can, it's not necessarily that you're gonna use a 3-piece sequence and result in another 3-piece sequence. You can add one piece, and then, for instance, if I have the 101 here, and then I see the T, I know I can place the T, and then I'll have a 0, 2, 1, if you can see that. Actually, I can bring this down with Fumen. Yeah, so see, this is equivalent to a 0, 2, 1 if I place the T like that. So then you can think about oh, I've got these next pieces. How can I place on a 0, 2, 1? Okay, so how did I generate all of these patterns in Fumen? There's a solution finder program. Solution finder. This is written by New Jade. This this program has been around for quite a long time, actually, and its solutions are used all over Tetris Wikipedia pages across the web. Like you'll see its outputs on pages like 4.lol and hard drop. See if I can find some example images here. Maybe not. Anyway, what this does is you can input sort of what you want as your grid, input a combination of pieces that you want the program to evaluate, and it'll say if a certain shape that you want as output can be reached. And you can do things like set whether or not hold is being used. You can set whether or not you want hard drop only, so the pieces can only be dropped in from the top. You can set whether soft drop is enabled, so sliding a piece under is possible. If you wanted to place an L here by hard drop, you couldn't. You see that, this L piece here? If you had hard drop only, then you could not place this, but if you had soft drop on, then you could soft drop the piece down and then slide it in. Unfortunately, this program out of the box does not do what I want. So I had to do a little bit of tinkering to get the desired effects. For instance, this program spits out a ton of duplicates. So one of the most important things was removing all the duplicates. And also rearranging the solution set in an ordered fashion so that they're not just randomly jumbled throughout the list of solutions. So if you take a look at this, you see that they're sort of organized in such a way that you see this L is always at the bottom. So we go through all those first. And then we have the O's at the bottom, and so on. This is named, this is ordered alphabetically, actually. Let's see if I can bring a new window in. I don't exactly remember all the changes I've made, but they were significant because they had to be done in order to make this solution set. Okay, I'm not going to go into this maybe another day, but it's not that interesting. If you're curious, you can put this into Fumen and see what it is and try to reverse engineer what it is that I was doing. Okay, so what else did I do here? Right, so on one of these, I think it was the 101, had a great example of one of the one of the main reasons why I had to modify Solution Finder. 101. Okay. So if we look here, you might have seen it. It was a piece placement that didn't look like the rest. Like, see, these are all 3, right? But one of these is just a T. So the problem with if I had allowed all 3 pieces instead of just the T, this solution set blows up. Okay, and this applies to every single of the patterns here. Because once you hit 0, 0, 0, 0, 0, then you can do all sorts of random unhelpful things. Like, for example, if I was on, you could do something like that, right? And then another solution would be something like that. And then another solution would be something like that. Or you'd have a solution that looks like this, another one that looks like this, another one that looks like this. It's it's not very helpful because since 0, 0, 0 is the most prominent one and the one you should study the most, um, there's no use in including that in the rest of these, right? Like another redundant one is you have this, and then you have this as a solution. So as you can see, this blows up extremely quickly, especially with 3 pieces total. So uh, one of the requirements was if you place a piece, so we place a total of 3 pieces. If you place one piece and it results in a flat field, then stop the search. There's another situation, okay? So you can have something like this, an S piece, so that's one piece. Then you can have an L piece, that's 2 pieces. Now you have a flat terrain again. You don't want to repeat, so we'd have the same problem again. We can place the J here, we could place the J here, we could place the J here. It's not very useful. Okay, so the program stops on the 2 height. So that's 0, 0, 1, and you'll see a ton of these. 0, 0, 1 has a lot of these 2P solutions. So you have the LO, OJ, you have the SL, and I believe that's it. Okay. So that was one of the major undertakings here, operations with 2 keys removed. So if you find a solution with 2 keys removed, which means 1 piece, then don't do the rest. And then if you find a solution with 1 piece removed, then don't do the rest. Otherwise, then find the solution with 3 pieces. Anything else? Yeah. That's the most interesting bit. Yeah, I can explain this another time, but this probably took half the time out of this whole project, was coming up with the optimal Fumens for. So like I said earlier, the solution the solution finder program takes inputs and spits out outputs, and then you can add some options of your own, like hard drop only, allow soft drop, etc. But you have to provide an initial space for the program to search against. So if we go here, so this one was the 010 Fumen. So here's, you can see this 010 pattern. This the cyan these cyan squares indicate pieces. They indicate squares in the output solution that must be filled. And the yellow indicates squares that may or may not be filled. So the problem here was knowing exactly how high to place this. Since we don't know all of the solutions, we don't know how high the grid can go, right? So like you could have like an eyepiece up here somehow. Maybe not this high, but like let's say there's a combination of pieces down here that allows you to place an eye up that high. So that means you'd have to place your yellows at least this high. Okay. But the problem is to find out what the maximum height you would need of this shape for the yellows to for each terrain. And that's because the problem takes the program takes a lot more time to calculate. I'm talking like perhaps even an order of magnitude for each couple of rows. Um, so for example, I think this was the optimal. Yeah, so this was the optimal. This was six units high. Let's say I had given this for the program to play with. This the original might have taken like half a second to calculate. Now I add this to the search space, and now it might take 1.5 seconds to 3 seconds to calculate. And if I had done something like this, now it might take 30 seconds to 15 minutes. Or in most cases, the program would OOM out of memory. So it was pretty annoying to figure out what the maximum pieces you would need. So I sort of wrote a program to automate finding the optimal solution for each of these heights, and so that's what you see here. So the program, if I need to regenerate the patterns, will run in optimal speed because the heights are at their max for each of the terrains. Okay, so what is the point of this session? Well, since we have all the patterns, we need a way to actually train them, right? Um, so one way, a primitive way to train these would be to use pencil and paper. Okay, so you take maybe a grid sheet and draw a bunch of these 001s, 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 right? 001, 001, and come up with all, say, 15 solutions for 001. That would work, but it's not very scalable. It's not very fast. It's annoying if you make a mistake. Uh, Nothing's automated. It's very manual and mechanical. So I needed to come up with a better way to train these. So, for example, if you wanted to train, say, 010, the program would prompt you, you need to find two solutions for 010, and then you would draw it in on the computer. How about some better? Okay, for 101, we know that there's 17 solutions because we've already computed them. The program would ask you, input all 17 solutions for 101, and then you can start drawing in. You have your S piece here, your S piece here, and your T, and then you can hit next, and then you can, not hit next, but then you can go move on, and now you can draw your S piece here, S piece here, and you draw your T. Let's say, because you wouldn't necessarily go in this order. Now you can draw your S, draw your T, draw your Z here, and now you've got 3 solutions down. What the training program that I'm going to be writing in this session and next is a way to keep track of all of these. So you would have to remember which solutions have already been found, and only increment the count if you're adding a unique solution. So if I, let's say I'm like, there's 17 here. Let's say I'm like 14 deep and I didn't remember all the solutions that I had already written down. And let's say I accidentally wrote down SST again. 14 wouldn't go to 15. You would stay at 14 because you have a duplicate. And my naive approach for that is to save each grid state Fumen string and just add it to a set of strings. So now you've got this program that's asking you, draw all 17 combinations for 101, and then you're drawing all of these. Great, okay. And then I realized there's another problem. Drawing all these takes time. You have to click up here. You have to precisely input the boxes, and it's just not a fun time. Okay, you see how slow that was. The point of this is to be ultra fast, so you can get through a solution set as fast, as closely as possible to how fast you can come up with solutions with your brain. And to do that, you absolutely cannot be clicking up here and manually drawing. So here are the two solutions for that. No manual clicking of the colors. We're going to have to do keyboard shortcuts. So let's say if you look at your keyboard, let's say QWERASD. Okay, so those are 7 keys. So this could be Q, this could be W, this could be E. Red could be the R. The shortcut to hit purple would be A, and then this blue for J would be the S, and then D for the green. So you can just hit the keys on your keyboard and it would automatically select these radio buttons. Okay, so that's one way to go about it. But you still have the problem of, like, let's say I hit W. I've got orange in my paintbrush now. I still have to draw the pieces, okay? And that's going to be slow. You have to be precise. If you make a mistake, then you have to, undo it, color in the right spot. It's just a mess. So what I'm thinking is somehow using this here. As you can see, this colors in the entire piece for you. But you'd have to click on each one. And if we assign each of these radio buttons a shortcut, that's 7 times 4. 28 individual keys for each piece and in each rotation. That's not going to be feasible. So another solution would be to spawn each piece in your hand in the spawn orientation. So that's just the piece, that's just the orientation that's given to you in the game when the piece spawns. So for all the pieces that are 3 blocks in height or width, they all spawn sideways or flat side down. The I piece spawns like this. Z spawns like this. And once we have that in our paintbrush, we'll have to use keys to rotate in place. So just like in a normal Tetris game, you have a piece and you have an active piece and you can just rotate it. So you just do the same thing here. I have this now. If I hit rotate counterclockwise, it should go to this. If I hit rotate clockwise, it should go to that. From here, right? This, then clockwise, it should go here. Actually, that gives me a really good idea. If I could somehow order these, and let's see if there's an ordering here. Not really, but Interesting. The rotate button could cycle through these four radio buttons. I don't know how I'm going to do that. Actually, I don't know how to do any of this because this is written in JavaScript and I am not a web programmer. I primarily do back end stuff. So the stuff that runs in the background that you don't see. Websites are a different beast, especially since JavaScript was, I believe the story goes, it was designed in 3 days. So it's a very messy language, and with all the iterations that have come out since, what, the 25 years that it's been written, just a bunch of duct tape and glue holding all this together. As new features are added, you'd have to work around the bad design that came when this was first designed. So you've got this terrible, messy language that is just patchwork on top of patchwork. So you might be wondering, why didn't they just, remove all the shoddy design aspects of the language and keep the good? The problem with that is backwards compatibility. So if you're removing stuff from a language, then previous versions that were using that older version of JavaScript will no longer work once they upgrade their frameworks or their libraries or their JavaScript versions. So if you're writing in JavaScript 1 using some feature, and then in JavaScript 3 they decide to remove that bad old feature, and you upgrade your libraries for your project to JavaScript 3 or beyond, all of a sudden your code doesn't work anymore because that feature's been removed from the language. I don't know how I got on a tangent about JavaScript, but right, I'm not a web developer, so this is going to be a learning experience. I do have to leave in an hour and a half, so let's see how much we can do in that time. I believe this runs without an internet connection, which means all of this is local. So all the code that's running to generate everything that you see here lives in this browser. It's got to, because it can work without an internet connection, which means none of this is going to a server. So that means we can probably inspect this and see all the code for it. Script. I mean, I've seen JavaScript enough to know that you can embed it within HTML. So that's what this is here. You can add the script tag, and then inside of it you have your JavaScript code, which is the language that the browser understands. This is where your logic goes, your for loops and your ifs, your method calls, just like any other language. Yeah, so it's pretty obvious. That's where all the logic is here. But this is not in a state that we can read, so we'll have to prettify it. Prettification? Pretty print. I'll have to run this through a pretty printer in order to make sense of what any of this is saying, because there's basically all white space removed, so that the server that's serving this web page can save on bandwidth costs. If they can reduce the amount of bytes that they're sending over the wire, then they're saving money, they're saving bandwidth. Actually, I'm curious to see what Google's is. Oh, I never mind. I'm not skilled enough to parse that quickly. Okay, so what we're gonna do is copy all of this and then try to make sense of it, because we're not gonna edit code like this here. Okay. So here's all the code. Shoot, where's it? Okay. I'm gonna paste it here. Actually, I should paste a version of this that is clean. So I'm gonna go to Fumen, reload the page so we get a fresh copy, and then take that instead. I'm not sure if we need that. Actually, what am I doing? If all the data is contained in this page, then we can just save the page. Version Fumen site. So let's go in there, save. So that should be enough. Where's Fumen site? Okay. So if we hit this, we should get something similar. Okay. So we're getting something weird. And it's small. Okay, so this top part looks like what we need. Interesting. Okay, so this is just cosmetic, it seems. So I'm gonna have to remove this at some point. But the point, so I'm gonna go on about the training tool. So I said we don't want to duplicate solutions, right? If we go back to this one, okay, so this one had 17 solutions. If we had 14 unique solutions that we had already input, SST, STJ, STI, and all that, and if we accidentally duplicate one deep in, like say on the 15th one, we supply another solution that we've already given, that should not count, okay? That should not count. And the way we identify duplicates is by comparing this Fumen output. So if we take a look at how Fumen works, so this this grid in this state, if you were to take this string and give it to someone else and they put it in Fumen, they would get exactly what you see here. So if you wanted to like draw something like that, it doesn't matter what the board state is. Notice that as I'm drawing, the string changes down here. Okay, so this string represents the board that you're seeing on the screen at that instance. Okay, so if I take if I take this, open a new Fumen, so let's say I had an idea and I was showing a friend. They could take this string and load it, and then they would get exactly what I was seeing here, right? These two tabs. And just to prove that this does what you think it does, do it one more time. Okay, so this even preserves the frames. I'm gonna get a drink. Okay, so this string will be the key to knowing whether a duplicate grid state has been inputted. And so, for example, if I new data. So if I found something like this, I don't know, I'm just drawing something random here. This, whatever this solution is, it's gonna look like that. So you can add it to like a list of these things, right? So you have a list, one that looks like that. I don't know, one that looks like this. So all these things are different. They may appear the same to the naked eye, but they're all different. They have to be. That one looks like this. See, and so on and so forth. And if one of them appears again, that's this one. Since it's a set, we don't. Nothing happens when you add it, because sets by definition only contain unique items. And I'm pretty sure JavaScript has a set. Yeah, the set lets you store unique values of anything. Okay. Of course it's got a set. Come on. JavaScript is used as a language in programming interviews too, so anything you can do in the main programming languages, Scala, Java, Python, Rust, you can do in JavaScript. At least for programming interviews. Okay, so this was the page that we downloaded. First things first, we have to be able to manipulate whatever's in this box. Okay, so this box contains the string of the Fumen. So anytime we submit a solution, this string here has to be sent to the set. Okay, so let's see what we can do about that. First thing you want to do is inspect and see what this is. So this is a attribute, I believe it's called text area. It has a name, TX. I'm guessing that stands for text. That's as much as I can glean from this. I'm pretty sure this is the table row, body, table. I don't really know what to do with that information, but at least we have this text box, and it's called TX. So what we're going to do is first prettify this up. Okay, and this was not it. Okay, this is the file. This is the file that's being displayed in the web page right now. So if we take script, there any other ones? Okay, so actually this looks like the top one and this one looks like the bottom one, that weird doppelganger. Okay, so let's find this top one. So here's the script. This is the end of the tag. So take all of this code, this JavaScript code, and run it through a pretty printer. I have to be careful to find the end. Okay, this looks like it's a JavaScript. This looks like the end tag. This script lines up with that script. That script lines up with that script. Okay, I think this is it. Okay. Yeah, definitely needs pretty printing. All of that is living within 4 lines. Okay, so that is a little more readable. Let's go to the top. Okay, so let's just make sure that we didn't break this. I'm gonna open this page again. Okay, great. And somehow that got rid of the doppelganger. Interesting. Okay. And I'm wondering if we can make this size a little bigger. Is there a size in here? Okay, there's plenty, and I don't know which one controls. I don't know why there's a second one down here. Anyway, doesn't matter. Until it does matter. Okay, so this looks like... Well, I have no idea what this is, but let's look for the TX. Search for whole word. Okay, this looks promising. ENCSTR, which clearly means encoded string, which is what this box is. This is the encoding for this grid. So ENC string looks promising. So remember that 159. And keep looking. Okay, we're seeing that again. TX value equals encoded string. But this is way down the page. This is already at line 1000. TX value equals location search. Okay, whatever that is. Okay, and we're back to the top. So ENC STR. Okay, looks like there's different versions for this string, for the encoding and decoding. Yeah, so here we have version 115. Looks like the developer made updates to this encoding. There was an 095, there was an 090, and then we're here at 115. So let's just try something here. If this is what I think it is, then this should show up. Okay, so let's auto output something here. Oh shoot, this doesn't even work. Nothing's happening. Okay, so I did something wrong. Let's just remove this entirely. See what happens. Funky. See, that's interesting because all I did was pretty print. I might have included or... yeah. I pretty printed part of this, so that's the HTML, which we don't want. I'm gonna undo that. Oh, that wasn't the final script. You see that? We included this piece of HTML, which should have been obvious now because I had an angle bracket as the last character. There. Okay. No, this should be it. All right. There we that's what we expected. So drawing, okay. Now we can go back to line 159. And do our little test again. So we should see this show up in the box if this piece of the code here is actually what controls what's in that box. Excuse me. Okay, I don't see the show up. It's not great. Maybe I didn't save. Oh, I see. This is actually affecting the grid, which is not what we want. Yeah, see? So this is not the right place. Maybe it's the other way around. TX value equals an encoded string. So this should not affect the grid, but it should at least affect the string. So show up, and then at the end we can append like a hey there. There we go. Show up, hey there. And as we change, that should remain. The show up and the hey there. Okay. So now we know this part of the code controls is what shows up here. So we could take this TX value and upon submission for that solution, store that to a set. So we'll have to make some changes to the UI. And I've already thought about this in, put it in my Trello. Okay, so first thing was to rip the Fumen. Okay, we've done that. Unobfuscate JavaScript and HTML. So I've dabbled with this before, so I know, like I've taken software engineering classes in college, and I knew that the, code would be, what is that word? It would be minimized I believe it's called JavaScript minify. Yeah, minify. To make it as small as possible to send over the wire. Okay, use an IDE. We're not doing that right now. We're just using a text editor. Yeah, so the keyboard shortcuts to choose a piece color. We discussed that. Rotations, we discussed that. This I haven't explained. This one I sort of explained. We need a button to add the Fumen string to sort of submit our solution as, hey, this is something we need created. So we need that button. So the button should do is get the Fumen, add to a set, and then clear the board and add the single gray piece, like 001, 101 onto the board. Visualize all 3 cell tries at that point. Yeah, so in order to make it easier to not duplicate a solution, especially when you get to the 000 with like 51 solutions, it'd be nice to be able to see the ones you've already tried. Otherwise, you're sitting there like, have I tried this? Have I tried this? And it can get frustrating if, especially if you're not getting feedback on what you've tried, and you start gaslighting yourself into doubting the program. Like, I've tried this. What are you talking about? What do you mean? What do you mean? Okay. So, this one will allow us to see the tries. So like over here on the side of the page, you'll see like the attempts you've already made that made it into the solution. I'll close out all these tabs. Okay, so the question is how to add the button, how to automatically create a new set. Like, if you're working on the 101 puzzle set, hitting submit should clear the board and add this back, right? Actually, we could just load this again. That's one way to do it. Yeah, if we were in a real IDE, I would just collapse all of this encoding code, because this is not really useful for our purposes to know how the board is converted to a little string. We do need shortcuts. So I think shortcuts will be the easiest to figure out first. Shortcuts. So for instance, if I press the Q button, this radio button should be highlighted. Okay, let's open this page. Let's see. You know what? Let's see if taking that out is going to damage anything. So that's down here. I don't know if there's a body tag here. So let's see. Let's find that body tag. I don't know what that is, but it looks like from this left margin 0, top margin 0, this is going to affect the whole page, so I don't think I want to mess with that. But this might be something we can mess with. This looks like JavaScript. Where's the last instance? Down here? Can we take this out? If we took this out, what would happen? Okay, did that break anything? Doesn't look like it. Okay, we have the code, so we can always put it back later if this somehow broke anything. But for now, I think we're okay. Okay. So let's leave that out for now. Yeah, so radio buttons. Okay. Skimmed over this earlier. This looks kind of janky. I don't know what these dollar signs mean, so I'll have to look that up. Access key. Okay, this looks easy enough. Access key equals S. All right. Where can we put that? Oh, right. We should prettify this HTML as well. I'm not sure if this will work. Don't know if I've copied the right sections. see. Okay, so what counts as HTML? Okay, I'm hoping this body and this body line up, and that this HTML lines up with that HTML. Let's just make sure that's the only one. Yeah, it is. Wow, that's super lucky. I think we have it. So this body lines up with this body. Getting a phone call. I think it's about the Facebook Marketplace item I'm selling. Okay, this is so ugly. This looks okay. Oh my god. How many levels deep is this? That's ridiculous. Is that even necessary? Let's make sure this still works. Okay. Auto output, show up, hey there. Okay, that looks good. Okay, let's just keep this for now. And now we can see radio. Oh my god. What the heck is this? No, what the actual heck is this? I can't even see anything. Let's see if this has indentation size. 2 tab space. How about something less, bro? How about like 2 spaces? Can we do that? HTML pretty. This is more reasonable. This is like this looks like 2 spaces. So I'm actually gonna undo this, paste that instead. There we go. That's way more reasonable than that indentation hell we saw earlier. Like that, I don't even think that was right because somebody had to program that and they wouldn't have gone out that far. Okay, IDE is showing 40 matches for radio, so I'm not about to. I'm moving my mic, so I'm not sure how differently the audio is going to sound. I'm not going to go through 40 ones by hand, so let's go through the site and inspect. See which radio button this is. This is mode. FE equals 1. Yeah, that seems like something we can search. And luckily that's the only one. Okay, so let's just see what happens here. Access key equals, what was it? Let's try Q. Let's see what happens. If I hit Q, this should light up if I did this right. No. Yeah, of course not. Input type equals radio. Is that what we have here? Access key equals B. Value equals B. Do I need that too? Or do I need Alt as well? I don't even know what key that is on a Mac keyboard. Okay, Control. Wait, what the heck? Oh, you know what? I'm actually not going to use Q. Because if I accidentally hit the wrong button, I'm going to quit the program. Or... I don't know, E. Hitting E, nothing's happening. Nothing's happening. Control E. Alt E. Command E? Nope. Yeah, that didn't do anything. Oh, you do need Alt. Oh, it's Control Option. Wait, how do I read this? Oh, Chrome. It's Control Option key or Control Option Shift key. So actually, let's try that. Control. What did it say? Control Option and key. So Control Option E. Bam. That was nice. It hit. You see that? And if I try it again, Control Option E. Cool. Now what is Control Option Shift E? Okay, they did the same thing. But you need Control and Option. Interesting. Not possible in HTML. JavaScript is needed. Use the key press event and call some function. Yeah, please. The heck does that even mean? That didn't do anything, so you'd actually have to get the character code. What was that? 72, 104? 72 is uppercase H. 104, lowercase h. Okay, so it's just ASCII. Let's see. So we need JavaScript $. The hell is that? $1 means nothing special to the interpreter. I see. So it's kind of part of the name, according to this. Let's see if we can find any other examples where somebody might be refuting what person 1 is saying. Okay, so this is a like interpolation, but it's definitely not being used like this with curly braces. So what is document? Okay, I don't know what this word means. Can you replace this with anything? Apparently. Or apparently not. Uncut reference. Okay, so can you print like this? Console .log document. Document. Okay, so it is a thing. It is a very important thing, it seems. This is a lot of stuff. The DOM document object. Yeah, okay, this is clearly the name of something very important that is just latent in the environment. Okay, we saw this earlier when we were looking at TX. Okay, so where does this code where does this code live? And do I have to install jQuery? I'm not sure how that works. Download See, what doesn't make sense is... Okay, I see. I wonder what is in here already. So you have this. Any libraries? Doesn't look like it, but we may have to include this. Let's include the same version that they have here. So jQuery 213. Inside the head section. What the heck is that? Head. No, so anywhere in here? Okay, it looks like they put it at the end. Okay, so maybe that'll work. I don't know. And I don't know if we need this min. Let's try this. Curious to see if I can just stick it here. Call some function. Okay, we definitely don't want this. Excuse me, I'm gonna close my mom's door. I wish they had shown that specific shortcut here to manipulate the radio button. Right, this is the piece of the code that I wanted in the other Stack Overflow page. E.target. Radio underscore 1 ID. Wait a second. Weren't all these IDs the same or not? F equals 1. ID mode. ID mode. That's not cool. I'm going to take this out as 2. ID mode. Don't really know what this means. Like, what's really happening when this is checked? On click FE equals 1. What is FE then? Whole word. Huh, looks like there's many values that FE could take on. And if we take a look at F equals 1, this is, there are 7 pieces, so these are the, this is gray, so if it was greater than or equal to 9, as we saw earlier, okay, so this is another piece of code that, I'm guessing this controls which are the radio buttons. Okay, which there are a ton of. Okay, let's continue. So is draw field being called each time? Oh shoot, never mind, there's 400 plus F equals 1. Why is this? Let me try this. Just to see what happens. So we can try out that jQuery piece of code. Then actually didn't even need to do all that. Just 1 would have been enough in the JavaScript. Wait, what's the difference between this and what he said? Okay, looks like he may have changed his answer. Dot trigger dot click. Dot trigger dot click. I don't know what that means, but we'll see. Okay, let's see. H, I believe this was. So, ooh, not cool. Look at that. All of these are selected, and the program doesn't like that. What is this? Yeah, that didn't do anything. Oh, and also this is not even the right mode. 1. Still? Interesting. Looks like the key this is taking over the keyboard. I have to take that out. We don't want that. Is this already... What is this called? Text. CM on focus. This dot select. On focus equals this dot select. How many? 6? It was this one, right? Okay, let's take this stuff out. Program doesn't look happy. Yeah, that was not... See what happens now. That makes sense. CM stands for comment. What is a vent button? EV button 1. Okay, cm.focus. That's probably it. Let's see what happens now. Did I save? There's another one down here. What is this? MD equals 36. There we go. I mean, this doesn't type, but it doesn't mean that the keyboard is... its focus is being moved somewhere we don't want it to be. Quick phone break. One more time. 28, 45, 25. Okay. I'm trying to sell something on Marketplace. I think I said that. I should put this in source control actually. Dang, I really should have put source control on this. Freak. Okay, I have an idea. Here's the code. I'm going to copy and paste it here. Now I'm going to undo all of this back until the pretty print. Okay, so we'll go to, is it Fumen site? I think get init. Okay. Okay, now we'll go here and apply these changes back. So we can have the differences. Shoot. No. This is the wrong thing. Oh no. I should not have I should not have undoed back to before the pretty print. I should have undoed to the pretty print. Shoot. Wait, I might still have this page open. Yes. Okay, we're back here. Great. And then I believe this. Everything within the body, right? No. Script. Okay. Similar behavior so far. 1786. Okay, so this is the state I want to save this in. So there's no changes except pretty. Uh, uh, I'm actually not going to paste what we had back into it because obviously something here was janked up because um, you couldn't tell, but I was not able to by default use gray on page load. Notice in the Fumen when you open a new one you can just start drawing, but that wasn't the case in this working page. But I still need this. Oh shoot, I have to pretty print this. Body, right? Just awesome. Body. I'm not gonna reuse this just in case I had messed it up earlier. Okay, let's make sure this is working. Okay, so far so good. Hmm. That's weird. I'm clicking. See, usually when you click and let go, that's only one piece shows up. Right now I'm clicking and it's staying. That's weird. Did it have anything to do with this? No. Maybe it has something to do with this. Oh, I also didn't include jQuery. Nope, that didn't do anything. Oh, shoot. Pretty print. This is... You know what? It's gonna be a pain, but... No, whatever. Okay, so it looks like this piece of code is what's being weird.
This might answer your question.
Alexa, stop. Does this have anything to do with it? Nope. Okay, I actually have to stop for the time being because I have a meeting, then another meeting, and then I have to do an interview, and that should be it. Oh man, this is gonna be a long day. I'm gonna have another meeting before the interview. 1, 2, 3, 4 meetings today, and I haven't slept. And my last meeting ends in 5 hours.